Vancouver Island is a real hotspot for kelp diversity, so it makes sense that BMSC should be involved in the research taking place on seaweeds. Today I tour the lab of our very own Tom Campbell. Tom is working as our assistant research coordinator for the Marine Station. However, he started here at first as a university student and then worked in the field trip program as an educator. Tom assists researchers who come from all over the world to do their studies here in Bamfield, but gets to do a little bit of research in his spare time as well. Tell me about your research at BMSC.
So globally, kelp forests are in decline, and to date, kelp forest restoration methods have been really expensive and really ineffective. So a number of researchers down in Australia have come up with this novel kelp forest restoration technique called green gravel. And essentially what you do is you seed rocks with kelp in the lab and raise them in the lab until they're a couple centimeters tall, at which point you then outplant them into the field. And it's quite simple. You actually just drop them right off of the deck of a boat. So this is really effective. It's really, really cheap. There's no cost for hiring commercial divers, no anchoring, no rigging. So it's a really cheap and really effective way to restore kelp beds. And what these researchers saw is even after planting the kelp in the field, they had really successful growth rates, and it was really, really effective. So they used a species called Saccharina lutissima, or sugar kelp, which we have here in Barkley Sound as well. And I'm going to see if this method is going to be feasible with two different species. Two species we have here, Nereocystis lupiana and Macrocystis pyrifera. So currently in the lab, I'm seeing if green gravel is an effective Nereocystis and Macrocystis kelp forest recovery method.
Okay, so have you experienced any setbacks in completing your research as planned?
Yes, absolutely I have. If there's one thing I've learned since coming to BMSC, it's that research projects never usually go quite as planned. And yeah, I've had a few setbacks. Namely, I've had some issues with contamination. So growing kelp in the lab can be quite difficult because you want to grow it in a sterile environment. But the conditions for kelp growth are actually quite similar for the conditions of other algae, mainly diatoms. So I'm seeing that in my samples, I do have a little bit of diatom contamination. And I'm hoping that it doesn't get to the point where the diatoms then overgrow the kelp and then cover the kelp. And then instead of growing kelp in the lab, I'm just growing diatoms on rocks. So that's been one challenge. And then another challenge is getting the kelp to progress through the natural life cycle. So as you guys probably know, kelp have an alternating generation. They have a sporophyte and a gametophyte. So the sporophytes produce spores, and that was the first step. I got the spores to be produced, and then I inoculated the rocks with those spores, and then those spores then grow into the male and female gametophytes, at which point they then produce the gametes, the sperm fertilizes the egg, and then subsequently you then have a sporophyte develop. And that's kind of what I'm hoping to see. What I'm actually seeing is that the gametophytes are kind of just growing indefinitely, and I haven't been able to observe any successful fertilization. I've observed sperm and I've observed eggs, but I haven't seen any development of the eggs after that. So currently my gametophytes are just growing vegetatively, so that's been a bit of a challenge to creating the right conditions, because that fertilization and then that transfer to the next generation, that depends on a lot of different environmental cues, which are often quite difficult to simulate in the lab.
What makes your work applicable to non-phycologists?
So having healthy kelp forests provides a lot of other ecosystem services. So for example, kelp are a foundation species, which means they play an important role in structuring the community. So with healthy kelp forests, you're also going to see a number of other species benefiting from that, whether it's young juvenile fish, whether that's other invertebrates. So kelp provides a number of ecosystem services. So with healthy kelp forests, you could also have healthier fisheries. Kelp forests have been known to prevent coastal erosion. So if there's any locations where maybe a beach is being washed away, you could plant a kelp forest there, and the kelp would actually absorb some of the impact from the waves and then reduce the force that's hitting the coastline. So improving fisheries and as well as preventing coastal erosion. Barkley Sound is a great place to perform the study because the species that I'm looking at, Nereocystis and Macrocystis, grow naturally here, and they form dense kelp forests here. And what we've been seeing sort of over 10, 20 years is that these kelp forests go through ebbs and flows with regards to their health. So they have good years, they have bad years, and the bad years are normally attributed to things like marine heat waves or herbivory by grazers like sea urchins. So with this sort of natural cycle, we can use that as an opportunity to see how effective these kelp forest restoration methods are. So if we're having a bad year, we can then use the green gravel to seed those beds and see if we can sort of mitigate these bad years that these kelps are having.